All right, so let's go over documenting requirements with use cases. And so the most common thing is that that happens is that when you go into these meetings with usually more focused groups of 3 to 5, you tend to create lots and lots of narratives, lots of writing. And usually you don't want to bring in actually using tools and dragging things around. People feel that the tool is like it hinders the conversation with these. Unless you're an expert with your tool and you can quickly drag and drop things and connect things real quick, and folks can see you actually work. Oftentimes much more effective to use just a whiteboard or a piece of paper. But the first part is typically to come up with a narrative of what it is that you're trying to capture, and then go on and document it and capture it formally. Again, these are languages that are mostly for us designers, right? For us to formally capture things, so that we know what we're doing. And so what we are trying to do is uncover what the requirements are, and oftentimes the stakeholders aren't the best folks to tell us exactly what they want, right? We have to kind of uncover it, spoon feed them, and again, so through several interviews, observations, workshops, and prototyping. So, and yeah, so we assume that they know what they want, but they most often don't. They're very unfamiliar what their process is, right? So it's unhelpful if we go and say, well, explain to me what the process is. Oftentimes, if we just want to let them ramble and ask circumspectal questions and says, okay, well, before we do that, if they're explaining, they usually jump in the middle of explaining what the process is, and it's okay to let them start wherever they want. It is then our job to then try to figure out where does that particular activity happen with respect or in relation to other activities. So they might they might ramble randomly explaining multiple activities, but then we have to go back and try to see which ones actually fit in what order. One of the aspects of one of the reasons, attitudes that we should have towards documenting anything is that it should be document enough, right? And that until the team feels with some level of confidence that you can go forward and start building. We should always see this as a tool. So it's a means to an end, not the end, not the end goal. So we don't document because we document because we document because we try to use it as a tool for communicate. So ideally, you would write the least amount of documentation necessary to communicate, right? But not less than it's necessary, right? So it's often the case that again there'll be a lot of back and forth, and when there's any misconception or somebody misunderstood something, we'll jump on the board and we'll write something there. And ideally, any documentation that you write, it becomes an artifact that somebody has to own it, right? And it has a life of its own. If nobody's going to be responsible for it, it's going to become stale. Any effort that goes into documenting something, you have to think about it. Well, how am I going to keep track of it? Right? How now that it's there, what is its life cycle that I can maintaining up to date? So oftentimes the developer's attitude will be, the documentation should be the source code. That's what it's built, and that's what it's actually running in production. That it's its own documentation. And there's certainly a lot of tools today that can extract documentation from source code. They can reverse engineer the source code and statically and dynamically and create diagrams for us that specify what are the relationships between the classes, sequence diagrams and state diagrams and whatnot from the source code, which is pretty cool. So again, the responsibility of the business analyst is to communicate, not to document. So don't Don't fall in the attitude of just documenting everything. Right. So, but certainly it does have its value, especially if you have a team that is not co-located. You have folks in India, you have some folks in Europe, and in Latin America working for the team, and there's a need oftentimes to have an asynchronous way of communication. You can't always have them participate in the meetings. Ideally, in agile teams, the most common is that everybody would be in the same room, right, in the same war room, and there's a lot of lively conversation. That it doesn't tend to work as well when you have folks that are remotely working. So you see a lot of the teams today. A lot of companies will do a lot of incentives for you to be physically in the office to work together. Oftentimes, your product, whatever you're producing, you're not going to be maintaining it. Right? Oftentimes, you're going to be moved around from one team to the next, and so you need folks to be able to be onboarded to take over for whatever work you were working on. Oftentimes, you have to document it for regulatory purposes, and oftentimes, ideally what you're going to be producing for the project, for the end of semester project, will be something that you give off to a developer and say, okay, well, go ahead and implement that. Ideally, in Agile, the developer would be part of of that process, and somebody would be taking your requirements and interacting with you, saying how great they are, or how inadequate, or some feedback, or something that they didn't understand that would be pushed back to you, and you would be going back between the business and the developer and trying to capture these things. Although we do that in the 4500 course, in the 5500, where we actually build something. Right, and so just like a developer is not gonna code something in a vacuum. That ideally they will be coding something based on some requirement because there's a business need. Same thing. The business analysts should not document for documentation purposes. They should always say, is this really needed? Do I really need to capture this class diagram, this sequence diagram? It'll be an effort. And can my resource be spent better elsewhere? Just one-on-one discussions and conversations, and oftentimes you have to take the role kind of like a parent, and your children, they kind of want to go their own way, and you kind of try to herd them and put them back where they go, and just repeat yourself over and over. It can be very tedious you'll be part of the leadership group, no? That you're gonna find yourself just repeating yourself over and over and over. Don't assume because you had a conversation and everybody seemed to agree and that's the end of it. It's not. It's just a long, prolonged process of educating everybody, and the bigger the team, the harder it is. So any effort that you could have of just having conversations, that's certainly considered to be more useful. We did mention that there are, I think we did, that there are in two large buckets of types of models that we document. Those that try to capture the system at a static moment in time, right? Either regardless of what events might come in, this is the static representation of the data, right? And how is it being stored? And then but there's also the other buckets, the dynamic model that tries to capture all the different events that come in and how the system reacts. Some of those events and reactions will be between human beings, right? Where a human manually actually interacts with another physical person. Other time will be interaction between human beings and some automated system. And we want to capture that what the data that is, what information is being transferred between the two folks or system and person, what being transmitted, what new data is being generated, what's the data flow, and how is the transition of these states, the system transitions over time. In particular, this presentation wants to focus a little bit more on the requirements from the point of view of the user. Right? So presumably, there'll be some real person touching and feeling and interacting with the system. So from their point of view, we would like to be able to capture what are the goals that they want to achieve, and how the system can instantiate a solution for them. We want to capture the what triggers this use case. What are we assuming that already the system is? The system might be in a particular state, and based on that state, a trigger event triggers the execution of this particular state. We'll describe who that person is, what their goals are, and what are the steps that they would follow to achieve that particular goal. So we document the interaction, what the goal, and how they achieve it. Whether the actors are interactions between humans or some human and some automated system. Typically, they're recorded as a short sentence, right? A verb phrase describing who the doer is, who is actually executing this action. The subject, on whether it's a record or items, and what is it that they're trying to do, and what transformation are they trying to do on that particular object. Examples: the cashier intends to record sale of items. The student intends to post an assignment. So these are typically the first line that describes in a simple sentence what are the goals, who the person is, and what their goal is, what they're trying to do. Oftentimes, we don't. These are not. Oftentimes, these are not evident, self-evident, and we have to start a little higher level, not from the user's point of view, but from the business point of view. Right? Oftentimes, we don't have access to the end user yet. Usually, we first have access to the executive team, right? The managers, the big bosses. And they're the ones who first will discuss their goals, and they'll be oftentimes fairly vague, and usually that's where we need to start to document the use cases, but from the business point of view, who are the various folks that interact with the system, with the business. And some of those folks will be end users, actual end users who are going to interact with the system, right? But oftentimes helps to start at the business level, right, and then drill down and be more specific from the user's point of view. The use case diagram, it's very simple. It's we usually use a stick figure to represent the actor. It doesn't necessarily have to be an actual person. It could be some other system. It could be a bank as well. It could be some cloud service that we interact with through some JSON data. But most often we mean a user who is manually touching and dragging and interacting with the system, trying to achieve something, right? Which we represent with an oval, with usually just a verb phrase, with 2 or 3 word sentences that capture the theme of that goal that they want to achieve. And this is a very, very high level, very brief set of diagrams that at a glance, right, that allows you to capture, says, oh, where's my use case? Oh, I see it right there. Without actually knowing what the details are, but certainly, you would be able to drill down, perhaps double click, and it would take you to a much more detailed description of the title, the actor, the pre, the post conditions, and the set of steps, right? And then you'd be able to drill down into from that use case down to functional requirements, right? That say, well, these are the screens and the forms and the buttons and the of actually implementing this and the class diagrams and whatnot. But anyway, so in the use case diagram, we capture the actor, the use case, and what's the association between the actor and the use case. And then also we can capture what the cardinality is of being how many of these there are per each record, per each use case. And certainly this could grow fairly complex, and you might find yourself repeating yourself, right? That there might be multiple use cases that are certainly specific to a set of actors, and others that would be common to multiple actors, right? So you might have use cases that are only used by a particular actor, and other use cases that might be used by multiple actors. And we'll see examples of those. So here are the just a diagram showing all the various possible pieces of a use case. So here are the use case themselves: payment, checkout, help, and whatnot, and showing the various types of actors. Here we have a customer, which presumably is a human actor. Here we have a clerk, with again presumably is another human actor. But again, the actor doesn't necessarily need to be a human being. Also notice that we have a multiplicity, saying that there can be multiple customers, right, that use the same use case. Also notice that this box around it somewhat tries to denote the context or the scope of what it is that we are trying to model. That this is a collection of a set of use cases that describe the checkout system, the checkout subsystem. Also, you can reuse use cases that where some use cases might be optional, right? Or some use cases might be required, right? That you cannot. That you might create some relationship of dependency between the use cases that you can't check out, until you have paid, right? Or at any one use case, you might have optional things, right? That there might be optional help available for that particular use case. Okay. So here's some actors represented in multiple diagrams. Certainly the stick figure, web client bank in the use cases, and typically in a class diagram might be represented as a class with the attributes and accessibility and the data types and whatnot. You might also create a hierarchy of types of users, presumably each one with individual roles, individual special cases that make them all distinct, but distinct in some ways, but very similar in others. So in the narrative of the use case, typically we want to be able to capture a very detailed set of steps that granular atomic steps, right? Presumably steps that you cannot subdivide. They have to exist, be executable atomically, each step, and we like to be able to capture both successful and unsuccessful scenario. It helps to start with the successful, right, the happy path, but it's not enough, right? Developers oftentimes complain that their business analysts only cover the successful path or the happy path, and that they haven't thought of all possible things that could go wrong, or a lot of edge cases, right? And certainly those edge cases are very important from the developer's point of view, so that we can generate tests that validate those use cases. Also, it's useful to, we need to document what are some of the assumptions that we take for a particular use case. We assume that they're logged in. We assume that they have an account, or we might assume that they have an assignment due, or we assume that they have added items to a shopping cart, right? So meaning that this use case is not going to address those things because some other use case might be handling those. How did the products get into the shopping cart? Well, that's another use case. Right? I'm assuming that that's done. Right? I'm going to focus on the checkout part, right? So preconditions allow you to set some assumptions on that from where you are then describing some of the details. Also, we like to capture some what would we expect after the actor has gone through these steps. What data has been generated afterwards, how the state of the system has changed over at the end of these steps, and these are very very important for the from the developer's point of view, that for them to develop test-driven software, right? They can validate against these post conditions. And certainly the documentation is not going to be in a vacuum. Certainly it'll refer to other documents, right? As it might refer to a sequence diagram. It might refer to a use case. To a class diagram, object diagram, or state diagram across the description of the use case, or some user interface or some prototype that has been previously done. So here's an example of a narrative this is a loan administrator, and so we have the start. What kicks off this use case? This use case starts when a check payment is received. Right. So that's a trigger for this use case. The loan administrator, so that's one of the actors, logs the check in the payment register. Right. So apparently we've identified the system, presumably a payment register, the actor who's acting on that register, and the type of information that they're entering. Again, the loan administrator, the actor identifies the loan account. The system looks up the loan account information and displays the information. So again, they're interacting back and forth between them. So we have here the loan administrator enters the loan amount, the check number, and the date of receipt, and the system allocates the payment to outstanding principal and interest. The system records the payment, and then it ends. Right, the use case ends when the loan administrator files a copy of the check in the loan recipient's file folder. So it looks like the recipient might be another actor, but they don't seem to be interacting with this, right? So it might be a separate set of use cases of how that might describe from the point of view of the recipient how is it that they start, how they submit the check, what kind of feedback they get from the system that they have that the payment has been recorded, and perhaps that the loan amount has gone down or the principal has been reduced. But this is from the point of view of the loan administrator. And so notice that in nowhere does it say about screens, buttons, links, or a particular set of forms. It does say the information that is being captured, right? The amount, the check number, the date. So it does say the information that is dependent, but nowhere does it make any commitment to any particular framework of how is that this is going to be implemented, right? Certainly, this might be implemented differently on a phone, on a web, or just a standalone ASCII piece of software, right? But that's left for other concerns of the design team to come up with a user interface for whatever they want to implement. But nevertheless, these are the steps that we have achieved, that we have identified. We would then further document as well what the preconditions are. So these are assumptions where we assume that the loan is active, that hasn't yet been paid off, right? Otherwise, this use case would have no meaning, and that we assume that the following conditions occur afterwards, right? That the state of the loan might change, right? If it's been paid off, or perhaps it'll, if it reaches a particular amount, right, and then it's paid off and it reaches zero, or over time, right, the amount is reduced, the interest and principal is reduced, right? There might be other business rules that might be captured elsewhere, either in a business rule catalog that we might refer to this, right? Usually all these use cases and rules have a unique identifier that either the business analyst might suggest what the naming convention might be, and then they can be referred to between documents. So presumably in the business catalog, you might have business rule R19, right? And then you can refer to those across multiple documents. Perhaps linked. If you click on that, it navigates back to the rule. And you have tons of these really cool tools today, like Jira and whatnot, that allow you to capture these in stories and link them together, so that it allows you to click on a particular issue and then navigates back to Confluence, where you can have all the documentation that documents that particular requirement. So we've been advancing more and more on actually implementing these ideas by creating effective tools that based on these processes. So requirements catalog might list rule R19 saying the loan administrator must be able to look up loan accounts by account number, loan recipient name. So again, no commitment on how is it that this is going to be implemented. Right? It'll be part of some design team to design 1 or 2 or 3 screens that would allow the loan administrator to look up the account. It could be a wizard, it could be a single page, that's not the concern of use cases, right? And requirements engineering. Variations that you might want to consider the alternatives, or if something goes wrong, some of these edge cases, and this is where a lot of us lack the documentation that oftentimes is left to as an afterthought, right? Or even by the time you go into, especially in Agile, right, where we might not even think about these edge cases up until it is time to actually implement it, right? That the business analyst and the PM, along with the developers, decide, well, let's implement this particular feature, and not until the developer starts actually implementing it, they start finding things that were not specified. That if I have a very long list, nobody said what we wanted to do with a very long list. Should we do a pagination? Should we do a search? And if is it going to be sorted? What's the original sorting? If it's multiple columns, what's the particular order of those columns? And if it's multivariable, so then is it going to be indexed, right, to be able to search it, to improve performance of searching? What are the most common searches that you might do on a set? Those all impinge on how you're going to go and actually implement it. So a lot of these edge cases are oftentimes missing, in these development, which is fine. I mean, in Agile, ideally you would perhaps leave them to design, just-in-time design. You design it right when you need it, right? And so these are open questions that. But again, the business needs to be open to understanding that indeed we might have not understood it enough to know these edge cases, right? Some of them perhaps yes, but a lot of them most often not. Right. So how do we find actors and use cases, and know whether they are appropriate and necessary use cases? So oftentimes it's not easy to get started with use cases, and we don't have access to the end users often early on in the process, and that oftentimes we need to step back and say and talk to the business owners, right? That at least from their point of view, what are the preliminary interactions of the system with all the identified folks that interact with it. So let's looking at the I think we had started this point of sale example in the previous lecture. I forget. I think we did, right? Like the barista and the folk who wants to order a cup of coffee, and I thought we did. So let's look at an example of a point of sale system, coffee chain, and what the requirements might be and use cases, and what are the inputs and the prospective users. So oftentimes, it helps to look at it from the business process point of view, instead of from the end user point of view, right? Now, one of the usually you start identifying many more folks that interact with the system but are actually outside of the scope of what we're trying to work with, right? In a system, for instance, in a coffee shop, you might have multiple folks that interact with the system, right? You have the vendors coming in the morning and dropping off all the coffee and food and whatnot, right? And you have the person who comes in and cleans and maintains the building. You have the finance guy that comes in and interacts with the business. So you might identify, when you look at the business process, you might identify a family of people that interact with the business, right? And of which a subset will be the actual users who you're trying to build the system for, right? So if it's not clear at first who the end user might be, oftentimes it helps with to start off at a higher level, right? Let's look at the process of the business first, and then try to identify who the customers are. So from the business process point of view, again, there might be multiple folks who interact with the coffee shop, of which a subset will be actual customers, right? And so we want to understand how the customer behaves in the context of the larger business, and so again, to measure their use cases, right, against the higher context. So the business use cases tend to be much more broader, right? Much more long running. They might have a horizon that is weeks, months, or the whole lifespan of the entire business. Whereas a user or customer's point of view or scenario or horizon might be just a couple of seconds, a couple of minutes. Oftentimes it helps to look at the use cases from these two different perspectives, right? From these two different point of view of participants. Also, we want to be able to. We like to identify, what are out of all those business process. A lot of them will be manual, right? You have to bring in the merchandise and put it on the shelves and whatnot. All of that will be manual, part of the business, but will have very little to do with anything that you need to automate, right? Ideally, from our point of view, as IT practitioners, we have to see, well, what can we automate, right? Anything that we see that somebody's doing manually, can that be automated? Can that be automated? Right? I see the person scanning all the time. Can that be automated? Can I just somehow move in and magically the bar beeps, or can I put an FRID in there that I can scan that automatically? So it's always a challenge for us to try to identify what are the things that can be automated and converted into system use cases. What the system is, those things that the user interacts with the system, that the system can automate a lot of that process, right? These will be what we are looking to do of creating the use cases that we're interested in, right? What the of documenting, but oftentimes it helps to start here at the business level, and then move down to more specific system use cases. Business use cases are documented just slightly different. They're typically just drawn with this additional line, right, to understand that we are a little bit higher level, right, that we're considering how the business interacts with all these folks, and yeah, so if we're looking, we're considering, what is the interaction of this business actor. This is, we typically add that additional slash there. So we would put slashes in these use case diagrams. Okay. So here's a couple of business use cases. The supplier, the advertiser in the system. And how it interacts with the business. The advertisers advertise, the suppliers provide the supply, candidates apply for a job. So these are very, very high level how the business operates, right? And then it would be our particular choice of what is it that we're going to focus on the project. Certainly, oftentimes we're not going to try to tackle the entire business. Oftentimes, projects come in to facilitate, the candidates or the suppliers or the advertisers or one specific subset of these actors, right? Certainly, the business use cases will be much broader and consider much more fundamental questions about the business itself. Do we have?
I have a question.
Yes.
For the diagram,
yep.
Is there a reason why the circle has a line in it?
Just to differentiate the abstraction level that we're talking about. Are we talking about from the business point of view, or are we looking at from the user's point of view, right? And they use exactly the same diagrams, right? The only difference is that we put a slash through it. That there are different abstraction levels. Yeah. Ideally, we could jump directly to the use case diagrams, but oftentimes it helps to start here, and then double click and drill down from a particular set of actors. And so from that point of view, from the user's point of actor, from the end user's point of view, none of these actors are relevant to their particular use case. Process narrative, business use case diagram. Oftentimes it helps to document workflow diagram. We'll come back to workflow diagrams. We'll see examples of those. So here's the use case. I thought we looked at this. The customer walks out to the coffee shop, right? And they start off the use case by ordering something at the cashier. They say they walk to the cashier and they order a beverage at the point of sale, and the cashier responds, okay, well, what is it that you'd like? And they jot down usually they'll write on a cup. Maybe they put the name on that person's name on the cup, and presumably they'll note it also on the order itself electronically. And the customer selects the payment type, and they pay either with their phone or cash or whatnot. And the cashier notes that records that the payment has gone through. And then the cashier might yell at the barista saying, a latte, whole milk, 2 sugars, blah blah blah, right? And the barista will start preparing the beverage, and then when the barista is done, they might put the beverage on a counter and call out the name of the person, and then when the person picks up the beverage and they leave, right? So that's the end of the use case. So it's oftentimes useful for to try and look at these and try and find optimizations, right? And writing it like this, folks can actually rehearse this, right? And play through many different iterations on how to best optimize this process, and come up with different conclusions, right? That they might conclude that it's better to have just a single line, or so they might conclude other, like Burger King does, or most everybody does, or you might conclude that it's better to have multiple lines, each line with a particular cashier, like McDonald's does, right? Or you might iterate over these multiple processes, and you might find that as the cashier hasn't yet taken the order, the barista might start yelling, "Hey, anybody want a drink, right? And just tell me what you want," and then you'll come up to the cashier and pay for it at some point, right? Trying to optimize. Well, I'll get started, right? So that by the time you're paying for it, your order will be almost done. But oftentimes it's very risky to try these things on the fly, and as while the process is running. Things might actually backfire, right? And people might feel that, wait, somebody's cutting in line, or why are you dealing with the guy behind me if I'm still haven't paid? So you might want to run these simulations and write them down. What are the possible risks and what things might go wrong? People might you're presumably relying on the baristas remembering what is it that you told me, and then maybe me changing my mind. I've already started working on something, and you change your mind when you're going to pay. So there's a lot of risks that might need to be captured here. All the things that could go wrong, right? So it is the responsibility of the business analyst to point these things out to the owner, right, of whoever's writing this, and only when you have it formally documented will these things come out, right? Because it might have been that they've been doing it like this for forever, and it turns out that there's actually better ways and more optimal ways of doing the same thing. So it's the business analyst's responsibility to challenge the business owner and the stakeholders on how things might be optimized, and point out, well, this is your current process, and these are other alternatives. Right. So the business use case are, again, they're fairly high level, and we need to identify out of those business use cases perhaps which ones could be automated, right? And how is it? What can we add to a system that a user might interact with them and improve the efficiency. Right. So many use cases, the actual granularity of the use case might not be obvious, especially if you have long steps that are not atomic steps that cannot be subdivided. Ideally, you might want to subdivide them even further and have special. It might be that a whole sentence you might discover that that might need an entire use case just to document a particular step. Again, but you would start from a business case at a very high level, very not granular, right? And you would start iterating and making further granular iterations. Again, the system use cases, right? We're looking for things that can be automated, right? Things that by the IT system, if we find anything that can be done by the system, we can create an algorithm or that can make it easier and add efficiency to the system. Probably maybe automated by different IT systems. Or maybe not everything, right? It could be that that automating something might introduce risk into the system, right? And that's also the responsibility of the business analyst. That you might want to push back. Do we need to automate this, right? What are the, especially when you're doing prioritization, right, and you're trying to look at the relative priorities of different things. What could we leave in place manually, right? That doesn't we don't want to that we might want to leave it, right? So again, that would come out in the prioritization steps. Here are some of the. I think before we were trying to identify the folks, the actors. We're trying to identify what are the different actions, activities, and verb phrases that perhaps we could automate. Notes on the order. So presumably, we're not just writing it on the cup, but we're also adding it to the into the system. Presumably, some monitor will show the name of the person and what beverage is what for who, right? So we can call out their names when we're done. Right. So visualizing the use cases, we're going to be using a couple of UML diagrams. Certainly, the use case diagrams are going to be useful, but in addition, we're going to be looking at activity diagrams. Right? So oftentimes the use cases are a little bit too dry and not graphical enough, and ideally they would be augmented by an activity diagram that uses either like a flowchart or uses swim lanes that lists who the multiple users are and how they interact with one another, right? How they communicate, and you would list step by step these activities in an activity diagram. So certainly activity diagram can augment use case diagrams to be a little more specific on how things are executed. So here's an example of an activity diagram that shows the workflow amongst multiple actors, the customer, the cashier, and the barista, and you would have the different activities that each one acts on. Right? So the customer places the order, then it's a turn of the cashier to respond to that order. So their activity might be to enter the order in the point of sale, records the customer names, and then it's time for the customer to. So this is kind of very synchronous. Right, it's your turn and my turn. We're going to dance together, right? And we need to synchronize and wait for each other. Sends the order to the barista, prepares the beverage, places the beverage. Now, notice that this is not taking into account any decisions whatsoever, right? It's assuming that everything's nice, everybody's doing what they're supposed to do, but certainly at any one point there could be a decision point, right? A decision point, considering multiple things that could go wrong. Ideally, it would be like as simple as this, right? It just flows through and you're done. But if there is a decision, typically the decision is documented, on the swim lane on who's making that decision, and the arrows that would flow depending on the result of that decision, right? Which we'll see a couple examples a little later. So here's an overall very high level general activity diagram that's also very useful to use along with use cases. Decision node, you have these diamonds. These decision nodes are not necessarily yes/no questions. You could have a one point of entry and multiple points of exit, right? Where each exit might have the reason for which following a particular flow. So this would be a question, and then you might have multiple answers from there. Then the actual activity, the doing something. This is presumably one single actor, or this is one single actor. If you have multiple actors, you would typically stack them. You would stack several of these together, each one in its own swim lane, right? So this is one single actor, and then there might be multiple actions that might occur simultaneously. While I might start off and put the sandwich in the oven. So while that's heating up, I might go and maybe get started on the next order, right? And then come back to that take out from the oven, and then and you can use these fork nodes and these join nodes that allow you to model these things that are happening in parallel. Yes?
How do you display something that can happen with a probability? Do you use one of the diamonds?
Yes, right. Like
So it's like a 30% or 70%.
oh yeah, certainly. So, right. So and here you would have guards, right? That bracketed reasons. You could have thresholds and say if it's within X and Y, right? Then you would follow this, right? And you could certainly have say that there would be a computation that calculates something, and depending on where it falls in a range, you can have 2, 3, 4 range, any ranges you want, right? Sure. Yeah.
So what does the fork node difference from the decision node?
Oh, this is not a decision. It's not a decision, right? These are either optional things that might happen. That you might have a guard here, right? That if this is true, then these two things could happen simultaneously.
Yeah. So can I try to understand it? The customer go with payment, right?
Yeah.
And so the no decision is order reject or order accept, right? So the order accept going to that, and the customer can choose to use the card to pay or use cash to pay.
Yeah.
So that's going to the fork node.
Well, no, but those are mutually exclusive, right? So typically, if they're mutually exclusive, right, like only one of them can happen, you would use a diamond, right? But if both could happen, right? And I mean, humans can't actually multitask, right? But if if like the example I said earlier, right, where I might put something in the oven, right, and I'm waiting for that to finish while that's happening, or you might have said, no, I don't want to heat it, right? So I don't put it in the oven, so I just continue sequentially. But things could happen simultaneously, where I'm kind of waiting on that, and I do something else, and I come back to it, right?
Yeah.
So if those two things are happening, and there might be multiple things that happen here, and just a few things here, right? Not necessarily have to be the same. And in here, you could have nested diamonds, right, where you have nested conditions. But at some point, things need to synchronize, right? Where I come to a point where I can't continue unless either both things have completed. So I can't give you a sandwich until it has come out of the oven, and I actually come back to you, and then I give you the sandwich. Here, the decision node, it has exactly the same figure or icon. It's an empty diamond, right? It's a merge node, right? There's no decision here, right? It's just waiting for several things to happen and come together and then continue. Now, typically there's only one initial node. You start off in one, but you could have multiple final nodes, right? Ideally, there could be a few successful endpoints, but you could have several maybe failures, right? That depending on some failures that might happen, right, you could end up in some failure node over here. So here's where you could use like priorities, or these could be ranges. You could write anything here you want, right? Within percentages and whatnot. Again, this was for one person. Right? If there's one actor, you might use this. But if you have multiple, you can aggregate them and use swim lanes, where you would have one swim lane per actor, right? And you have commuters, ticket vendors, and banks, where presumably these are two. I'm sorry, there's one human, one human actor, and two systems. So the commuter starts the session, maybe with their phone. They request a trip info. What's the trip info? They process the trip info. They say, well, now you have to pay, provide the payment. The payment can be either card or cash. Okay, all right, this must be the vending machine, not the phone. And you insert the cash, or if it's a card, then you authorize the card payment. So here's a join node, right? This is the decision node, and this is a join node. If it's typically if you want to also capture more information about the information that is being consumed or generated by one and consumed by the other. You might be more specific, right, on what is that you're capturing. This too, right? Trip info. You could perhaps have here an additional box there that says trip info, and usually that'd be maybe some class diagram that tells you exactly what are the attributes for that class. Trip info class, right? You can see the attributes, the data types, and whatnot, right? So here's the ticket, get the info, dispense, charge. So this is a this is very useful to capture an alternative way to graphically capture what the use cases are between the different actors. Here's yet another example. The author creates a draft. So here's the capture of that data model. The reviewer reviews the draft and provides a review document. The approver approves. And notice that the approver has a decision point, right? That decision point is captured on the swim lane of the person who's making that decision, right? So is the approver, it is the approver who is deciding whether to approve or not to approve, right? So if it's not approved, it goes back here and then updated, and then presumably the author would update the document, right, and then resubmit for the approval. If it's approved, here's the document between the owner document, the effective document, but the reviewer review effective. What? Oh, okay. Reviews the effective document. Whether they review it, either archive it, or give it that it can be changed and goes back to the author for updates. Okay. Again, very useful. This is another one, real quick. This is an electronic prescription service. We have the prescriber creates an electronic prescription, goes off to the electronic prescription service. These are a little bit different in that in this case over here. These typically are meant to be modeling synchronous communication between the systems, right? Where I create the electronic prescription, right? And and then I'm kind of waiting for the prescription to come back so I can continue, right? In other cases, notice here we try to document and capture an asynchronous communication, right? Where I send out a notification. This kind of like I'm not waiting for your response, but I send the notification. I'm not blocked. I can't. I could continue doing something else without you without waiting for your response. And so this denotes this event or this messaging, asynchronous messaging between the two systems. The schedule is endorsed, and then there's a callback. There's a callback that comes back to me saying, okay, here's the schedule, right? And here we're documenting something that is recurring, right? That happens on a particular day, or whether it happens every week or happens every hour. That gets kind of like interrupts us, right? Sending us an event, and then the event is generated here in the dispenser and it's handled by the reimbursement agency that is sent over as an interrupt that is being handled by the reimbursement agency actor. This is for one single person resolving software issues. Someone, so presumably a QA engineer generates creates a ticket, or somebody found a bug, and they try to reproduce the issue. If they can't reproduce, they just update the ticket as not reproducible. If they can reproduce it, then they issue reproduced. Okay, they identify the issue, they fix it, they determine the resolution, they fix it, they verify the fix, and then they close the ticket. Right? If it's a known issue, then it says, okay, well, I know it is. I'm not going to close it. I have updated for later. It'll go back in the backlog to be triaged at a later date. Okay, there's a whole bunch of examples here. All right, so this is the one we did earlier, right? The point of sale workflow model. We did that, right? Right, from the flow that we looked earlier, from this workflow here, we can identify a couple of system use cases of where an actor is actually interacting with the system. Right? What can we do? What do we need to build? Well, that's what we need to build, right? Something where the interaction points occur, right? Things that happen manually, we don't have control over, right? Certainly, we model it in the business model, in the business process modeling, but the part that we need to actually build is the ones where some human being is interacting with the system. And we saw that there's an enter beverage order and record payment. So those are certainly interaction points of the user and the system. And we can capture, again, the narrative and the activity diagrams, functional and non-functional requirements. So here's a couple of capturing those two cases, enter beverage order and record payment. And we've identified a dependency between these use cases, right? That one of them has to occur before the other one, right? That one depends on the other. So to enter the beverage order, I first need to record the customer's name, right? So we capture that through an include, right? That this depends on the other. It's not optional, right? It has to occur before the other. So use case. So let's look at the normal scenarios and some alternate. So here's the again the original description of the narrative of the process starts when it places the order. Cashier enters the beverage order. Cashier asks for the customer. So basically this is the use case, right? Having identified the actors. And can we think of, and so this would be the resulting use case diagram, right, where we have places order, pays for order, picks up order, the barista prepares the order, delivers the order, calls out customer's name, the cashier places the order in the point of sale, notes name on order, records. So this is a very, very quick way of having distilled, right, all these use cases, right? You can very quickly consume this and see, whether the use case is missing or not, right? And it forces you to write it in such a way that is very atomic, right? That and you should always ask, is it necessary, to go a little further and break this into much more granular steps, right? Is it even useful, especially for implementation? Here's some of the variations on the what could go wrong, right? What could go wrong in each one of these steps? We can document it, embed it in each one of the steps, like sub-steps, right? Like the cashier enters the beverage, and right after the cashier submits the order, right? The customer changes their mind, says, "Oh no, I don't want whole milk. I want skim milk, right? Oh, I don't want a small. I want a medium." And so, what do you do, right? So you would document all those use cases. If if the system can't handle those exceptions, then the business won't run. It says, "Oh, well, I entered it. What do I do?" Right? So you would list here how would the system handle that, or you might ask for a particular thing that we just don't have it, right? We're out of stock. And the cashier informs the customer, the customer cancels and leaves, or the customer changes the order, and back to step one, right? Again, this is kind of like pseudocode that it's leaving the details to later designers, engineers to come up with. Okay, well, what would be the best user experience that would allow us to implement something like that, right? And the user experience folks might come up with 3, 4, 5 different alternatives on how to instantiate these requirements, right? And they would run their usability tests on multiple multiple alternatives, and then we weed out the ones that are not as useful. Other variations, they place the order, calls out the customer name, and puts a beverage on the counter, and the customer comes and says, no, this is not what I ordered, right? I ordered it this way. And oh, this is too sweet. This is not what I ordered. So I didn't want. So you get the wrong beverage. So what do I do? So you need to be able to handle those kinds of things, right? Certainly from a business point of view, you might have a very high level policy that we always make the client happy. We don't ask questions or are rude or say, well, sorry, you get what we gave you. So that might be the business drive on what does it mean that the client is always happy, always make the client happy, and then it would be instantiated, right, in a certain set of actual steps that how is it that we're going to make the client happy. Customer complains to the cashier, customer complains to the barista, or customer places a new order, go to one, or just customer leaves, or the barista calls the wrong name or mispronounces it, or and how to handle that. Now, some of the some of the goals and use cases might be repeatable or things that always happen that needs to happen first before certain things happen. So include allows you to kind of reuse common use cases that need to occur before others, right? So include allows you to do a reusability. Other ways to capture this is to perhaps create a bigger oval where you have a top level goal, and then underneath you might have smaller ovals, right, included in a bigger one. Those are kind of alternatives of capturing the same thing. Now, unless you have too many, then it would become unwieldy. Extend allows us to capture things that are optional, right? And it might be that we might provide the same option across the entire system, right? So you would just draw extend lines to the use cases that reuse that particular other use case. Right. So includes is a functionality that must be completed before you continue, and whereas extends things that are optional that you don't need to complete. So here's a couple examples where checkout, to be able to be checkout, you need to have completed scanning and calculating the total tax and the payment. For a bank ATM transaction, you have to have first authenticated. Here's an optional if you're registering, and if you have trouble registering, well, there's an optional get help on registration. Bank ATMs, you can have help to be able to deposit funds or withdraw cash. You have to have authenticated the customer. You can also use inheritance or special cases, right? When you say that this is a special case of a more general use case, right? That might allow you also to reuse some of these use cases. So you would only specify the things that are special, right? So this would inherit all the steps, all the pre or post conditions, right? And here you would only specify the things that are different from that base use case. Right, so ideally the easier thing to do is to start with the happy path, and anyway that is the easiest thing to do, and then over several iterations go and identify what all the various variations and then alternate exceptions, and again it helps to start off with the business rule first and link them to the other requirements. If the use case becomes unwieldy and it's way too complex and it has a lot of decision points, then perhaps the use case is not the best place to start. use cases tend to be fairly linear when you don't have too many decisions to make. If there are indeed too many decisions, but a better alternative is to use an activity diagram where you can do all this flow and these questions and whatnot, right? Yeah, so they're very useful all throughout the design diagrams. Yeah, so we identify a couple of diagrams that are useful. The use cases are certainly the activity. Class diagrams. Did we do class diagrams? Did we do them last week? Maybe. I don't know if we did a couple of those as well.
Yeah.
And state diagrams. If we see that we need to identify, what the life cycle of a particular data set, how a particular ticket evolves over time, or state allows us to capture those intricate rules. Certainly, UML is not the answer to everything. Wireframing and doing some usability testing, that's certainly not its UML strong point. We would use other types of diagrams. Certainly, it's useful to start with the actors, identify the use cases, do a lot of paragraph, normal, identify the normal flow and the variations. And use business rules and decision tables and link them all together. Certainly remember to put pre and post conditions, activity diagrams, wireframes. All right, I think we're all set. Any questions?